All right, this lesson's for those that missed our intro to chemical reactions, intro to chapter 6. What we did first was did a little bit of a preview and read pages 225 to 226 and tried numbers 1 to 5 on 227. Students did that on their own and before we started today's lesson. And then we started by defining a chemical reaction, which is a chemical change in which starting materials called reactants form new substances called products. And of course, pause this video anytime you feel you need to catch up. This should be going into your notes, so there should be lots of pausing and things like that. The way that we represent chemical reaction is reactants, arrow, products. I got that sequenced a little wrong. So reactants on the left, products on the right, with an arrow in between. That's how you model a chemical reaction. Word equations uses the names, the written names of reactants and products. For example, hydrogen plus oxygen gives you water, and this is a good spot to pause and try and catch up, all right? Another example is propane plus oxygen gives you carbon dioxide and water. The reactants are chemicals present at the start and used up during the reaction. So our reactants here are propane and oxygen. And our products are the chemicals that are produced during a reaction. So in that case, it's carbon dioxide and water. The purpose of the arrow tells you the direction of the chemical reaction. In this course, it's always going to point from left to right. So our reactants will always go on the left and products always on the right. And the arrow means that it produces, forms, or yields something. So you'd say that propane and oxygen give you carbon dioxide and water. So our first two examples are right word equations for this. So this is a bit of a throwback to our naming ionic compounds because we've got Na2SO4 and LiCl react to form. So that's where your arrow would be, NaCl and Li2SO4. So we write that as sodium, because that's your Na, sulfate plus lithium chloride give us sodium chloride and, I ran out of room here, lithium sulfate. Now, the next one's a little tricky. It says oxygen and glucose are produced when plants perform photosynthesis. The reactants are carbon dioxide and water. So what goes on the left? The reactants go on the left. So it's carbon dioxide and water, carbon dioxide and water. I'm just trying to make sure I have enough space. Usually you write them on the same line, arrow. And we're going to put oxygen and glucose. Next example is CaCl2 and Na2SO4. They react to form CaSO4 and NaCl. So this is a bit of a long one to write out, so bear with me. It's going to be calcium chloride plus sodium sulfate gives us calcium sulfate. Ooh, I'm going to have to write really small to fit this, sodium chloride. Normally you would write this all in one line, but I ran a little bit short on space here. So that's just the way I have to do it on this PowerPoint. And then finally, we've got BaCO3 reacts when heated to produce BaO and CO2. So that's going to be barium carbonate reacts when heated to produce barium oxide plus carbon dioxide. And that prefix method, the die for the oxide, comes from the lesson on names and formulas for molecular compounds. So those were the word equations. Now we'll transition to chemical equations. Chemical equations use chemical formulas of the reactants and products to write out your equations. So for example, H2 plus O2 yields H2O. That's hydrogen gas plus oxygen gas gives you H2O water. So this is the chemical formula. I like this better. It uses up less space, less time consuming. The state of the chemical can be represented in a chemical equation by common state symbols. Solid, S means solid, L means liquid, G means gas, and AQ means aqueous, which means it's dissolved in a solution of water. Let me go back a slide and show you what I mean. So I know that hydrogen is a gas, so you put a G in brackets. I know that oxygen is a gas, so you put a G in brackets. And I know that H2O is a liquid, so we put an L in brackets. Pause it at any time if you need to get caught up. Write a chemical equation for the following. Na2SO4, no problem. Na2SO4. And I'm going to put most ionic solids when they react are dissolved in water. So we're going to write AQ beside each of these plus lithium chloride, LiCl. And I'm going to put AQ yields NaCl. AQ plus Li2SO4, also AQ. Most ionic compounds are dissolved in water when they react like this. Next, we've got oxygen and glucose are produced. Oh, this the same photosynthesis example, except we're going to put carbon dioxide. Carbon means one carbon, dioxide means two oxygen, plus water. We should know that that's H2O. Yields glucose and oxygen. So that's going to be O2 plus glucose is H6O. No, that's not right. That's C6H12O6. There we go. There we go. That's, you don't have to have that memorized or anything. That just happens to be the chemical formula for glucose, which is like sugar, regular sugar. CO2 is a gas. Water, of course, is a liquid. Oxygen is a gas. And you could say that the sugar comes out as solid, or probably it's dissolved in a liquid. So let's say AQ. Last one is AgNO3. So I'm going to start with that. AgNO3, aqueous, plus KCl, aqueous, produces AgCl, all going to be aqueous, they're all ionic compounds, plus KNO3Q. All right, pause it here if you need to catch up. This is just taking words and turning them into formulas. So burning charcoal, just some more examples. We got carbon plus oxygen gives me carbon dioxide gas. Write the word equation. So that's going to be carbon plus oxygen yields carbon dioxide. Write the word equation, done. Write the state of each substance. The carbon is solid, the oxygen is gas, and the carbon dioxide is also gas. What evidence do we have that a chemical reaction took place? Well, if you're burning anything, and also in the chemical equation, the arrow. What would you expect to see when this reaction is completed? Expect to see nothing. When it's complete, everything's turned into carbon dioxide, and carbon dioxide is a clear colorless gas. One more here. Solid zinc reacts with aqueous copper 2 sulfate to yield a copper precipitate and aqueous zinc sulfate. Precipitate means it's a solid. So let's write the chemical equation. Zinc, solid zinc, so let's go Zn, put an S for solid, reacts with copper 2 sulfate. So copper 2 sulfate is copper with a 2 plus, and SO4 sulfate also has a 2 charge or 2 minus. When you crisscross them and then reduce it, it's CuSO4. That's a U. and that's aqueous. It says so right in the words. Put an arrow, and then it gives you a copper precipitate, so that means solid copper, plus aqueous zinc sulfate. So that's ZnSO4. The zinc has a 2 charge, and the sulfate, of course, still has a -2 charge. And they crisscross and cancel out just the same. I've just got to put my AQ on there. What's the name of the solid produced? That's the copper solid. That's the precipitate. Write the state of each substance. We have that up there. Solid, aqueous, solid, aqueous. And what's the name of the reactant solution? The word solution means the aqueous thing, and reactant means on the left, so that is your copper sulfate solution. All right, so if you're following along at home, you should pause here and attempt to do numbers 1 to 5 on 227, and now add 7 and 8. Also, you should have read that section. If you've already done that, then we're talking about moving on to measuring masses. Don't write that down or that. Let's start right here. The balancing chemical equations is the last thing that we learned in this day. A chemical equation must reflect the law of conservation of mass, and the law of conservation of mass is basically the mass of the reactants must equal the mass of the products. Don't forget to pause this video and catch up as you need to. This is done by balancing the reactants atoms and the products atoms. Again, pause and catch up. And the rest of this note is examples, balancing these reactions. So in this, you have to think about, okay, I need the same number of atoms on the left as I do on the right. By that, I mean I need the same sodiums on the left and the right. But on the right, I have 2 sodiums. On the left, I have 1 sodium. So I can balance those by using what are called coefficients. Let's start with the sodium. 2 sodiums there. This is a coefficient. It's a big whole number in front to balance it. It multiplies through the whole compound if you have a compound. In this case, there's no compound, it's just sodium. So I've got 2 sodiums now on the left, 2 NAs, and I got 2 sodiums on the right, 2 NAs. How many oxygens do I have on the left? Pause it and think about it. On the left, I have 2 oxygens. On the right, I only have 1 oxygen. So to balance that out, I have to use a coefficient. You cannot jam them into the middle of the compound. They have to go out front of the compound. So that actually changes my number of sodiums, right? Now I have 4 sodiums, 2 oxygens. On this side, I have 2 oxygens. So my oxygens are happy, oxygen, oxygen, but I threw my sodiums out of whack. So I got to change that. Do this in pencil because there's lots of erasing to do. And I have to go 4. So now I have 4 sodiums and 2 oxygens. Now everything's balanced. You use these coefficients to balance your chemical equations. So in grade 10, there's 2 types of balancing that we're going to deal with. Simple, which means no polyatomic ions, which means the best piece of advice I can give you is balance the lone atoms last. Let's try one. H2 plus O2 gives me H2O. So on the left, how many hydrogens do I have? 2. On the right, how many hydrogens do I have? 2. How many oxygens do I have on the left? 2. How many oxygens do I have on the right? Just 1. So I need a coefficient here to get my oxygens up to 2. Now I have 2 oxygens on the right and on the left, so they are balanced. How many hydrogens do I now have on the right? It's 4. 2 times 2. To get 4 hydrogens on the left, I need another coefficient of 2 here. Now I've got 4 hydrogens there. I've got 2 oxygens here. I've got 4 hydrogens, and 2 multiplies, don't forget, by both of these, and it's 2 oxygens. So everything is balanced, and this one is done. When I'm collecting these from you, I don't care what work you show, just that you have the right coefficients in the right places. Let's keep doing some examples. I got N2 gas and chlorine gas making NCl3. So to make the nitrogens balanced, just first, I've got 2 on the left and only 1 on the right. Put a 2 here and the nitrogens are balanced. I've got 2 here and I've got 2 there. That throws my chlorines out of whack. How many chlorines do I have if this multiplies through? 2 times 3 chlorines is 6. The only way to make this 6 chlorines is to multiply by 3. Now I have 6 chlorines. I have 2 nitrogens, I've got 2 nitrogens, and now I have 6 chlorines. So everything is happy and it is done. Now, sometimes you're faced with a word equation. Aluminum and oxygen yield aluminum oxide. So I got to go aluminum. I'm not even going to worry about the solid and gas and stuff like that right now. We're trying to balance equations here, not worry about that other stuff. I do have to recognize, however, that O2 is what oxygen gas is. And it makes, what's it going to make? Let's say aluminum's got a 3 charge, 3 plus, and oxygen's got a 2 charge, 2 minus. When we crisscross those, it'll be Al2O3. Let's balance the aluminum first. Actually, no, I want to balance the oxygen first. So that's going to make a 2 here and a 3 here. See what I did there? 3 times 2 is the same as 2 times 3 with the oxygen. So I've got 6 on both sides. How many aluminums do I now have on the right side? I have 4 aluminums. 4 aluminums, 2 times 2. So you just stick a 4 here and it is done. Pause these, think about them. Pause them before I do the solutions. Try them on your own. You should be trying a few on your own at this point. In this next one, I'm going to start with, I think, balancing the oxygens. I'm going to go 4 here. That's going to make 4 oxygens. I would say pause it. I've given you a start. Pause it at this point and see how far you can get it before you have to restart the video. And I've got 4 oxygens on this side. Next, let's think about the hydrogens. I've got how many hydrogens on this side? 4 times 2 is 8 hydrogens. How do I get 8 over here? I multiply by 4. 4 times 2 is 8 hydrogens. They're balanced. Oxygens are balanced and hydrogens are balanced. Last thing to do is worry about the irons. 3 irons on the right, 1 iron on the left. Multiply it by 3, and this thing is balanced. So the other type is equations with the polyatomic ions, which can be found at the top of your periodic table. And a good rule to follow is keep the polyatomic ions together. So in the example, AgNO3 yields plus copper yields copper nitrate and silver. So what we have to do here is I'm going to suggest that you first balance the nitrates. So I've got 2 nitrates here. That's not just, that 2 outside just acts on the NO3, right? So I want 2 over here. How am I going to get 2? You can't add your own subscripts. You got to multiply the whole compound by 2. So I put a 2 there. Now I've got 2 nitrates, 2 NO3s. Over here I've got 2 NO3s. So what I did is I just balanced my nitrates. They're happy. Let's check the coppers. I got 1 copper on the left and I still have 1 copper on the right. That 2 out here only acts on the nitrate. So the copper's good. Copper's good. Last thing to worry about is the silver. I have 2 silvers on this side, 2 Ags because I multiplied it by 2. So I just need 2 over here. So I added 2 on the right. Now I've got 2 silvers and I'm confident that this is correct. And lastly, and probably the toughest ones to do are combustion reactions. And what I suggest for combustion reactions is just start trying to balance it and see what you can do. So I'm going to just choose for no apparent reason that I've got 4 hydrogens over on the left side. How can I make 4 over here? I can multiply that H2 by 2. That throws my oxygens a little bit out of whack because what do I have here? 2 oxygens. Oh, another 2 oxygens, which makes a total of 4 oxygens. So on the left, I've got to get 4 oxygens. How can I get 4 oxygens? Multiply that one by 2. Now I've got 4 oxygens. Oxygens are happy. My hydrogens are happy. I've got 4 hydrogens over here. Anything else to balance? The carbons, the carbons, the carbons. And that's going to throw my oxygens off a bit. So I've got 2 carbons on the left and only 1 on the right. So I got to multiply by 2. So now, instead of just 2 oxygens there, I've got 4 oxygens, which makes a total of 6. No problem. Just change the coefficient there. How can I make that equal to 6? I go 3 times 2. And I know I'm flying really fast. You pause it, you think about it, and you email me questions when you need to ask them. One more combustion reaction, C2H6 plus O2 gives me CO2 and H2O. Same sort of deal. And what am I going to start with this time? I suppose I'm going to start by balancing the carbons. And then I'm going to look at the hydrogens. I've got 6 hydrogens on that side. How can I make this one into 6? I multiply by 3. So now I have 6 hydrogens, 6 hydrogens, so they're happy. I've got 2 carbons, and over here I've got 2 carbons, so they're happy. What's left? Just oxygen. So let's think. I'm going to erase this now. I'm going to erase both because I know the other ones are happy. And I'm going to say, okay, so this gave me 3 oxygens and this gave me 4 oxygens for a total of 7 oxygens. So how the heck can I multiply this guy right here, the O2, to make 7 oxygens? The answer is 3.5. Now you can't leave 3.5. Note, must have whole number coefficients. If you have a 0.5, double all your coefficients. So let me erase this, pause it to get caught up mentally, and I'm going to multiply this entire thing by 2. So it's going to be 2C2H6 plus 7 O2 yields 4 CO2 plus 6 H2O. I multiplied that 2 by every compound in the chemical equation, and that is now balanced, right? So what you can do for more practice is do page 236, numbers 2 to 8. There's a worksheet posted online called, I think, Balancing Practice or something like that. And then you'll see in a separate post a balancing assignment. And actually, let me get out of this presentation and I'll keep my annotations. Now I'll discard them. Just to show you where this stuff is, let's go back to where our work is posted. So if you want just some practice in balancing chemical equations, there's a bunch of them here. Now, if you're a little unsure of it to do on your own, I would only go up to number 8. Then they do get very, very much more difficult. All right. However, if you want the answers to them, there's also a picture of the answers posted. Someone did point out, I think, that number 30 had an issue with it, and we investigated and that was correct. There's a mistake in the answers to number 30. If you're looking for the assignment, let's see here, right down here, balancing chemical reaction assignment. It's just one document. I want you to submit it on Docs. There's a copy for each of you. You can just type your coefficients right into this. It says it's out of 15, but there's actually only 14 questions. So I'll just mark it out of 14. I think number 9 is missing. And you should be able to fight your way through that. That should be handed in at the very latest sometime tomorrow. So if you're sitting at home, this should be really what you focus on doing. If you send me a picture of what you're working on with your phone and say, hey, does this look right? I will tell you, or I'll give you hints on how you can fix it. All right, I think that's all for me for now. So for the 3 or 4 of you that were away today, good luck doing that. And then email me if you have any issues through Classroom, okay? Or you can just ask me tomorrow, all right? Good luck, guys.